You don't need to have a scientific diving certification to take part in NOAA's Young of Year Rockfish Survey program. Actually, the more recreational scuba divers out there collecting data, the more valuable the program becomes. That's because there's a lack of data on rockfish in the Salish Sea, which is a major problem given that 2 of the nearly 30 species are listed under the Endangered Species Act. With your help, community scientists around the Sound can inform restoration efforts and effective policy. If you're a scuba diver interested in adding a twist of science to your next splash, here's how you can get involved. Before we get into the methods, the first rule of collecting data for this incredibly important program is to not stress about it. No data are worth putting yourself in a spot where you feel unsafe. For the purpose of this project, we're interested in collecting data on baby rockfish, or rockfish that are born within the last year, hence Young of Year rockfish, or YELLOWEYE. Unless you know something that we don't, it's quite difficult to age a rockfish by looking at it, so we count any rockfish that are less than 10 centimeters. Think a fish shorter than the height of a pop can, or my personal favorite, since rockfish rock, you can use the rockfish hand signal as your own personal measuring device. Rock on! We also realized that Young of Year rockfish are hard and in some cases impossible to correctly identify to species. So we're not going to ask you to do that. Instead, once you've determined that you have identified a rockfish 10 centimeters or less, all you have to do is record the body type and whether or not it has a dorsal spot. This resource from the Seattle Aquarium shows the various YELLOWEYE you may encounter. If you want to give this guide another look, it's also available online. Being able to identify and count Young of Year rockfish is the first step, but this information becomes even more valuable when we pair these data with 3 key pieces of information: survey time, depth, and habitat type. Survey time allows us to account for differing dive lengths. Finding 4 rockfish during a 10-minute dive is way different than finding 4 during a 60-minute dive. Rockfish species are known to differentially occupy depth zones and habitats, so keeping track of where we see the YELLOWEYE is just as important as the total number we count. Depth is broken into 3 bins: shallow, 20 feet or less, intermediate, 21 to 60 feet, and deep, anything greater than 60 feet. And finally, note the habitat you're surveying in. Options include rocky reef, both natural and artificial, kelp forests, soft bottom habitats, and eelgrass beds. This might sound like a lot of work, and it might be if you haven't collected data underwater before, but that's okay. Take it slow and team up with some of the capable volunteer divers at Harbor WildWatch and Tacoma Scuba Dive Club. Now, if you've gone this far and think, those data are super easy to collect, I want to provide even more information, you're in luck. There is an option to add further data on habitat. You do not need to collect these data if you're uncomfortable, but you're certainly welcome to listen on and hear about the whole process. So let's review the extra questions, starting with reefs. If you're surveying a rocky reef, there are 4 questions. Number 1, is it a natural or artificial reef? Natural reefs include areas like the clay wall at Day Island or Sunrise Beach Park. Artificial reefs include the riprap at Les Davis or the pilings at Dickman Mill. Question number 2, what is the height of the reef relief? Is it high, greater than 1 meter, medium, 0.1 to 1 meter, or low, less than 0.1 meters? Question number 3, how much seaweed is attached to the reef? We want to know if the seaweed attached to the reef is absent, rare, occasional, or common. And finally, question number 4. What was the percent cover of reef in your survey area? Here's a couple examples to better understand this percent cover question. For a survey along the middle of a wall, you'd likely have 100% reef cover. For a survey along the bottom of a wall, you might have 70% reef cover because you're mostly focused on the wall, but you're also observing 30% of sandy habitat at the base of the wall. And then let's say you're peeking around the pilings of an artificial reef. You might observe that the reef cover is only 40% because the majority of that area is a soft bottom habitat. In all these cases, don't stress, your best estimate is great. Another habitat type you're likely to encounter is an eelgrass bed. These will be found in shallow habitats of the Puget Sound, so this is a great survey to do during your 3-minute safety stop. There are 3 questions when it comes to eelgrass. Number 1, how tall is the eelgrass? Again, your best estimate is great, there's no need to bring a ruler. Question number 2, what is the density of eelgrass shoots in a square meter? There is certainly no need to hand count each shoot. Instead, look at an average eelgrass patch and imagine a meter by meter square. If it looks like there are more than 75 shoots in that area, the density is high. If there are 15 to 75 shoots per square meter, the density is medium. And the density is low if there is less than 15 shoots per meter squared. Question number 3. What is the percent cover of eelgrass in the area you're surveying? Were you in the thick of the eelgrass for the majority of your survey with rarely a patch of sand to be seen? Then you can probably estimate your percent cover to be over 90%. Or perhaps, as you were doing your safety stop, you came across a patch of eelgrass and only spent about half of your time there. That sounds like an estimate closer to 50%. Again, your best is great. The third habitat type we're interested in is soft bottom habitats. These areas often make up the spare percent cover of our previous habitats. There are 3 things to take note of. Number 1, what type of sediment do you observe? You should record whether the area is comprised of silt, mud, sand, gravel, cobble, or a combination. Question number 2, what is the percent cover of soft bottom habitat surveyed? And the final question, is there unattached seaweed? You should note whether unattached seaweed is common, occasional, rare, or absent. Finally, if you find yourself lucky enough to be diving in a kelp forest, there are 4 additional observations to record in this type of a habitat. Number 1, what species is the kelp? In the Puget Sound, it's most likely going to be bull kelp. Question number 2, what is the kelp canopy height? Question number 3, what is the percent cover of kelp? And question number 4, what is the density of kelp stipes? Do you only see a few stipes here and there? Are they common? Or is it a bit of a challenge to swim through because the kelp is so dense? Again, this extra information about the habitat type should only be collected if you feel comfortable doing so. We can still learn a lot off of simply knowing the habitat type, depth, and number of YELLOWEYE counted during a timed survey. Now that you're stoked to add data collection to your next dive, you might be wondering what gear you need beyond the typical scuba gear. All it is? A slate. And if you join me for a rockfish training, you can borrow a handy-dandy rockfish slate made by the incredible team spearheading this effort via the Paua Marine Research Group and NOAA. But really, any slate will do. You will use your slate to record the amount of time you spend surveying a habitat at a particular depth and of course the number of YELLOWEYE observed. Don't forget, zeros are important too. You may have already guessed it, but you can conduct multiple surveys on a single dive. I like to stabilize around a specific depth, and when I enter a discrete habitat, I'll write down a start time, my depth, and a note for the habitat type. If I observe a YELLOWEYE, I'll make a tally with a note about the YELLOWEYE description, whether it's deep body or elongate, and whether or not it has a dorsal spot. I'll continue adding tallies as I see more fish. I might also add notes on the amount of algae present or the sediment type, but most of the qualitative data can be recorded after the dive. When I'm ready to shift to a new depth or habitat type, I'll record a stop time. This stop time often serves as the start time for my next survey, where I'll add a new line for habitat type, depth, and YELLOWEYE observations. Again, when I'm done with this survey, I'll record a stop time and either keep making observations for additional surveys, or call it good because the dive is ending, or maybe it's time to stop surveying to hang out with an incredible GPO you just crossed paths with. When it comes to collecting data, you are the community scientist and you can decide what is right and safe for you. If all you want to do is a survey during your 3-minute safety stop at 20 feet, then you already have half the information we need. Just report the number of yelloweye and habitat type, and blammo, that's a rockfish survey, and we will gladly take that information. However you decide to add data collection to your scuba diving adventures, it's a good idea to transfer your slate data to a datasheet as soon as possible after your dive. I don't know about you, but sometimes it's hard to interpret my underwater handwriting, so translating my scribbles while they're fresh in my memory is ideal. Plus, the datasheet will help cue reminders for some of the qualitative data that goes along with each habitat type, such as the height of the reef, or density of the eelgrass, or amount of loose seaweed on the mudflat. It's also easier, in my opinion, to do the time math for total minutes surveyed for each discrete depth and habitat type when I'm not submerged. The datasheet will also have general information to record, such as the date, the dive site, your time in the water, visibility, water temperature, and the names of the ever so treasured community science scuba divers on your team. If you enter all this data onto a datasheet, it's so easy to take a picture and send that our way so we can submit your observations. And there you have it, folks. We hope that you will consider adding a twist of science to your next dive and join us on our mission to better understand rockfish in the Puget Sound. Rock on, all you rockfish divers! And as always, learn, have fun,